Welcome back, everybody. It's been a crazy couple of weeks, months for me between the holidays and being sick, but I'm pretty excited to get back into wrapping up the pop-up headlights. We still have a lot of work to do, but I've made a lot of progress on the design so far. I was hoping to go through this video and talk about going from my initial concept layouts like this guy, where it's very rudimentary, nothing really lines up, obviously doesn't function as you see that it's going through the light bar, and how I got to where I am currently with the full version where I'm starting to add gears and mechanisms and everything's starting to open and not hit the light bar. So without too much rambling, let's get through my thought process on how I got to where I am now, and then I'll do some CAD overview and a voiceover talking about how I did this part of the mechanism. So at an overview, the biggest thing I did was I started doodling and coming up with how I wanted to lay things out, like is it even possible, doing measurements, the scanning, what you guys have seen in the previous videos. And now that I was able to get that into CAD, I was able to give myself this guy, which is like a bounding box of this is the envelope I have to stay within. And with that, I was able to start building out and kind of sculpting what goes on the inside. But before I start adding gears and mechanisms and motors and all that, I have to find out what movement system would work. So this was my first stab at it in CAD, and that was using a single door that would ride on two rails and slide up. Now clearly that doesn't work because it goes through the light bar. Now my buddy pointed out I think it's a Cavalier back in like the 70s or 80s. It had a pop-up headlight or a pop-open headlight which had two doors that would sandwich open, and that led into doing my second mechanism of this guy. So it was very similar. This was still two pins in slots, but changing to the two doors gave me a lot more maneuverability around the light bar, and I could get the light bar a lot tighter to the door versus in the other one I was going to have it hanging way out the back just to clear the door or have it super low. So in this one, you can see that it clears up here. The light bar is currently a little off center. But if I move the light bar up, it clears both sides. So that was definitely a step in the right direction and brought me to go into like my first transition into a fully functioning prototype. That's where we landed here, where I started actually building out, having a motor, having bearings and bolts, and transitioning to something that would actually function, that I could try 3D printing and playing with. Now I was starting to like it, and I was starting to run into a lot of hiccups, size constraints, stuff lining up and fitting, but I knew I was on the right track. Now this design had me kind of concerned because of the potential for racking, where you don't really have a fixed side and the whole thing can be free to move this way. So it has a lot of wiggle room, and the chance for binding kind of goes through the roof. I don't think that this wouldn't work. I believe this would work, but I don't think it's robust enough for what I wanted. So I went through another kind of play around and mess around, try to figure out how to do it better. And this is what I ended up with, of making it a single pinned joint. Let's swing around this way. And again, this is me in my transition period a little bit, where I just did dummy CAD. These bodies don't really mean anything yet. They're just representations so I can play with the geometry. But I was able to take a pinned socket right here, and then I have a straight pull arm. So this guy just goes straight back. You can see that wiggles in here. In the subsequent designs, this gets locked And through tolerancing, I'm able to have it just move straight in and out, which is a much easier mechanism to achieve rather than having a bunch of individual arms. Now again, this was the layout just to prove that the geometries would work, that I could still clear the door, that I could actually make it pull in. And I did have to add a double jointed arm down here. And that's because I can't just have it swing up because it would hit the bezel, or what will eventually be the bezel. So this way, as it starts to pull in, it clears the bezel and then retracts the door up. It's still a little complicated for what I want, but I'm pretty happy with where we're going with this design. A lot of this, figuring this out, was me doodling and just trying to come up with a concept that would work. We're gonna jump to the end of the video where we're gonna talk about where we've transitioned to now. We have the mechanism, it's got gears, I've started to spec out parts. In this transition, this is all located the same way as it is in this one. Let's see if we can get a side by side. Right? So it's very similar, does the same thing, where it moves straight backwards. You can see here, it begins to hinge, it clears the bezel, so it pulls the door in, and then as it just keeps pulling straight back, it pulls the door up. And it's super tight to the light bar, which I could probably make it tighter. I just wanted to give myself plenty of wiggle room. That way, if there's size differences in light bars that people want to use, or if I end up changing light bars, I have plenty of wiggle room for what I can do. But so in the rest of the video is going to be the CAD where I went from the previous model, this guy, and I'm going to do a voiceover where I talk about probably not all of it, but a lot of key things I do and how I work through getting to this point where I have a built out model, and it's just constant sculpting and tweaking and kind of assumptions I make to slowly build it out, and then eventually you just keep working through a loop where you build everything up to a point that you like. So I think I've talked long enough. Let's get into the boring part of the CAD and I'll talk about it. I'm just working with the model that I was speaking about earlier that just had this straight pull actuation arm. And I'm just going through the joint, as it's called in Fusion, and editing my limits so I can see what the total travel has to be. Once I got it where I liked it, I selected my other components that I've had from previous testing and playing around with, and I'm moving them into their new positions that fit inside of my bounding box. I do a lot of toggling on and off and spinning around and looking around, so I chopped a lot of that out so it's easier for you guys to see. Here I'm using the in-software McMaster tool that's embedded in Fusion 360. I did that mostly for the video. Generally I have a McMaster tab open on Google, and I do all my looking there, and then I simply just take the McMaster number that it has and I copy and paste that into Fusion to do the import of whatever file I want to use. The one that's inside of Fusion, it's kind of broken and it keeps like resetting and rebooting every time you go into it. So I like to just keep McMaster open and copy over the part number or the McMaster number into it. Next, something that's really important when you're working with gears is getting the pitch diameters correct. The pitch diameter is the point where two gears need to be concise with one another, basically line to line, as you see I'm doing it here, in order to mesh properly. Now, I gave it a little bit more of a gap, but that's because I intend to 3D print this linear rack. But usually gears give you a diameter that the pitch diameter is, But with a rack, a linear rack, it tells you a height for what your pitch diameter is. So it's important to make those line up or add in some tolerance like I did in order to absorb the printing tolerance so that way it meshes properly. Now again, now that I've got the rack and I've kind of figured out spatially how big it needs to be, I'm just going to keep moving and trying to get things into what their home will eventually be. With things starting to line up, I'm going to make some final adjustments, and I say final, but some temporary adjustments to try to beef things up. Because I believe these holes that you're looking at are only like an 1/8 inch in diameter, and I think I want to go something a little more robust, more like a 1/4-20 or maybe a 3/16 might be okay, just to try to make it a little bit stronger. With the rack in place where I roughly want it, now the next thing is to make the rack, when the gear turns, to pull on the upper door latch. And that's what I'm doing here, is slowly beginning to model using the rack as my initial reference drawing point, so that way I capture all that geometry. And then I'm pretty much just going to add on an arm that will eventually be the pivot point and slowly build that out. When you have drawings like this where you capture a lot of geometry behind it as, you know, a reference, you can run into issues where you miss a little tiny corner. So make sure you either select everything, so you don't get like thin little holes in your models, or try to delete out as much of that as possible. This will make more sense in a second, but I'm going through and now making what will be the sliding mechanism or the sliding retainer. Now I do a really good job here of fully defining my sketch. Usually when I first start out, my sketches are really blue. Like they're not great. And as I get farther and farther along, I will begin defining, or once I get farther along in the design process, everything starts to become defined right off the bat. And that's what I'm doing here. Now that donut there is what's going to be the mount for the lower arm, and I'm going to be working on incorporating that into this one sliding mechanism. So we'll slowly try to build it out so it's all one piece that gets printed and bolted together. So as you can see, the gear is going to sit on top and hold the rack down for the most part, and then the sliding mechanism, or the slide part of the gear mechanism, is going to be what really retains it left, right, up, and down. And those gaps, which I believe were 10 thou, are mostly just for printing tolerance. Ideally, that's going to be not line to line, but as tight a fit that gets us a nice smooth sliding. So I'll be adjusting those tolerances and working that in at a later date. And I would say that's probably one of the more important reasons why to have a fully defined sketch. Like I said, it doesn't always happen, but now that I'm getting farther along in my engineering career, having fully defined sketches, albeit it takes a little bit longer up front, you do start to get quicker at it, and it pays off in the long run of if you just want to go change something really quick, you go to that sketch, you change the geometry, change your dimension, and then bada bing, bada boom, it all auto updates. Now, I'm not super in love with this two-piece lower arm that I have going on. I think it works really nice because it lets the door pull in first before moving up. So that way I can have a really shallow bezel angle. And that bezel, why it's important, because I want this door to push forward and basically seal. Realistically, I want you to barely notice that this is there until those doors open up. So having something that seals, it doesn't have a gap, is really important to me. Because I could make it a fixed arm, and then if I change that angle of the bezel to exceed whatever the tangential line is that comes off the radius, I know I'm throwing a lot of words, but if I do all that, I could make it so that way it clears and doesn't interfere. But I like this a lot more because it'll pull the door in and then move it up, and vice versa. When it comes down, it'll move into position and then push against that flat face and effectively seal the door. And this is more of just taking my geometry that I had pre-existing and connecting the points in space, slowly building out new bodies and trying to determine what I want. Sometimes Fusion does this weird thing where you're just trying to make, you extrude a face down to meet another one, and it ends up being some microscopic height difference that it can't tell you, like it's in like 10 to the negative 5 or something height difference. And you either have to remodel, resketch everything, extrude it just right for it to line up to make it happy. Sometimes you can get away and just click on the line and delete it. But sometimes you kind of just have to live with it or put in a lot more effort than you really want to spend to make it happen. Moving on to the next part, because now I'm starting to get really happy with how the upper mechanism is starting to come out. And ideally, I'm going to design one side and then mirror it all and put it on the left-hand side of the light. But now I have a couple of obstacles to overcome that I've kind of thought through before this point, and I'm going to try to implement here. So unfortunately, you can't just mirror it down, because if you did that and you put the gear all the way at the bottom, when it actuates the gear, if I just put a belt from top to bottom, the gear is going to want to spin in the same direction. So it would actually try to push the door more up. So as you're going to see as I get through this next modeling part, I bring everything down and maintain having the gear on top of the rack instead of mirroring it, which would have the gear below the rack. This way, I can very easily just add a belt that goes from top to bottom without having to have a jack shaft or some sort of complicated gear mechanism to flip the rotation of the gear below. And that way, when it pulls open, it's a simple mechanism top to bottom, and everything moves in one go. I'm really trying to do this all with one servo, just so I don't have to have two servos fighting each other or binding. And that's why you have that big long rod that goes from left to right. Because again, ideally, you'll have one servo at one end that does all the movement for both sides. We'll have to go through some testing, but I'm really hoping that we can just scale this lengthwise by adding longer brackets and longer rods that will do the rotation. So this was just me trying to figure out and get it in place, because as you can see, the bolt hole doesn't quite line up on the lower rack because the gear below has to clear the light bar, so that way the rod can make it to the other side to effectively turn the other gear mechanism that'll be on the opposite end. But luckily, it's going to move in a linear fashion, so I'll just be modifying this to work with the lower one, so that way it'll just probably have like a higher bulb that comes up and hooks it up. So it'll effectively do the same thing, but in a slightly different fashion. Now, it was starting to get late, and I was starting to get really frustrated with making the mates work, so I called it quits for here and decided to start working on this video. All right, so we're not quite as far along in the design process as I wanted to be, but with how I'm trying to be as transparent and show as much as I can of the CAD, at least whatever I try to deem the interesting part of the CAD is, I think we're in a really good direction for having a prototype, printing something out for the next video where we're actually opening the door and playing with it, and maybe even start to get to do some coding. So in the interest of condensing and trying to keep this stack up as short as possible and also as cheap as possible, trying to maintain having a single servo that operates at one end. And the way I think it's going to work out is you're going to have this servo driving this rod. There'll be the same gear mechanism like this over here with a belt that goes from top to bottom. And the belt makes it the easiest to connect them, tension it. I could probably put a little pre-tensioner, and then it makes everything rotate all in one go. I'm not fighting with servos or balancing loads, but maybe that's easier and I just don't know it. So if you have an idea or think I can improve somewhere, please jump down in the comments below, make some suggestions. I'm really hoping to have an actual functioning model, probably not the end all be all, but something that we can play with and see how it operates. Until next time, thanks for hanging around, and I'll see you in the next one.